Good day, I'm Jing and my matching number is U2103161. For this video, I'm going to be presenting about circuit in practice, designing Wheatstone bridge. Let's begin with the introduction of Wheatstone bridge. A Wheatstone bridge is an electrical circuit that measures an unknown electrical resistance by balancing two legs of a bridge circuit. It is formed by four resistors, R1, R2, R3, and R4 joining end to end to form a complete loop in a Wheatstone bridge. Invasive pressure monitoring CT scan are a few examples of the medical devices that utilize the Wheatstone bridge. A strain gauge is a sensor whose resistance varies with applied force. Four strain gauge components are electronically connected to produce a Wheatstone bridge circuit in the strain gauge circuit. Moving on to the methodology of designing Wheatstone bridge.
Four resistors are chosen. The resistors are labeled as R1, R2, R3, and R4. The apparatus is set up as a Wheatstone bridge circuit based on the diagram above. Two batteries are placed into the battery holder and actual voltage of battery is measured. The voltage VG is measured and recorded.
The first diagram shows circuit diagram of designated Wheatstone bridge, while the second diagram is the block diagram of designated Wheatstone bridge. The values of stated voltage and actual voltage of battery are tabulated in Table 1. The second table shows the respective values of resistors. The reading of voltage VG across nodes C and D on a multimeter are tabulated in Table 3. This is the formula used to obtain the theoretical values of VG for the imbalanced Wheatstone bridge circuit. By substituting values of Vs, which is the voltage of the power supply, in this case it is a battery, and the values of R1 to R4 into this formula. The calculated value of VG obtained is 1.369 volt, with the experimental value of VG equals 1.274 volt. Percentage of error obtained is 6.94%. These are the assumptions made in this experiment. For this case study, there's a minor difference between the actual and the theoretical values since some voltage is lost due to the existence of internal resistance of battery. As we can see, the calculated value of VG obtained is 1.369 volt, while the experimental value is 1.274 volt. This is because when a 3-volt battery is connected to a multimeter, it displays a reading of 2.427 volt. And these are the measures that should be followed during this experiment to ensure the precision of the result acquired. We can avoid using long connecting wire to reduce current loss. Next, we must ensure that the resistors and the connecting wire are tightly inserted into the breadboard so that the circuit is complete. Besides, the probes of the multimeter need to be polished so that the rust layer on the probe can be removed to ensure its sensitivity. That's all for this video, and thank you for listening.